in the very first example, it's just 3 variables, ME, HE, math. But now we're gonna make the mediation model a little bit more complicated. And still, we are going to use all of this software to do the data analysis. In the second session, we are going to talk about another model. It's not a mediation, it's called the moderation. Moderation and mediation. Some people got confused about these 2 models. They thought they're the same, but actually they're totally different. Okay, I will show you what's a moderation, how to conduct a moderation analysis. But before we talk about the mediation and the moderation, let's look at our homework 3 and 4. For homework 3, it's all of you, okay, almost all of you did a great job. Just explanation, the code of the R and M plus. Just one point, just one keyword in the M plus code. Some people remember that we needed to specify the variance of ME, HE, and the math. Okay, the residual math. So we use a name, okay, ME and semicolon, HE semicolon, and the math semicolons. Actually, those are for variance, not an independent variable. Some people said, okay, that means, okay, we include ME or HE as an independent variable in the model. That's not correct. A variable name listed in the code means we are going to calculate the variance of that variable. If that is a dependent variable, we are going to calculate the variance of the residual of that dependent variable. Okay, so it's not just a variable specified in the model. And what else? And also, yeah, so in the R code part, I ask you, okay, so we use a $sign and we have a lot of matrix. Okay, we have J, we have P, we have A, we have S. The S matrix in the R code is not the S matrix in our slides. In our slides, the S matrix is symmetric to store the double-headed arrow. But in the S code, in the R code, the S matrix means a sample covariance matrix. It's a sample-based covariance matrix. That is S. Okay, don't just get confused about these metrics. We introduced a lot of matrix. So that's it. So some of you didn't get a full credit, didn't get a 10, but still you are doing a great job. So so we're gonna talk about, we're gonna skip homework 3, and for homework 4, I would like to ask the student come here to talk about her homework 4. So it's Yin here, Yin Chen stuff here. Okay, then I'm gonna look at her homework and okay, so that's her work, and she's not here, so I'm gonna talk about her solutions. So basically, that's our question. This is the model you are going to do the test. Okay, so we assume that the mother's education gonna directly influence the home environment, which directly influence the math achievement. So there's no relationship between ME and the math. Okay, that's a model. So we assume the mother's education will not influence the math achievements. And we have the variance part, S1, S2, S3. So you need to provide the code if the code is the first step, you made a mistake. Actually, basically, you got nothing because you cannot answer the rest part correctly. So the first step is really important. So some students didn't get the first step correctly. So please resubmit your code. Okay, resubmit your homework 4, because I would like to give you a second chance to update your scores. And then the second part, okay, you need to provide the output. Okay, what is the model fit indexes? What are the model results, estimation results? And then the third step, you're gonna do some explanation of your parameter estimate. For example, B, we have some B estimate. some students just explain, okay, B equals some number. That's not enough. I need the explanation of this B. What does that mean? Is that significant or not? Why significant? What is a p-value? Okay, what is the estimate? What is standard error? Just report all of this based on the APA style, because in your final project, you're gonna do this step. After you got the result, you're gonna explain, okay, what is this estimate? What's the meaning of this estimate? What is the standard error of this estimate? What is the p-value? If the alpha level is 0.05, is that significant or not? So you're gonna do the explanation. That's third step. And the fourth step, evaluate this model. Is that good or not? And the last step, why? Why it's good? Why it's not good? You needed to provide some reasons to support your conclusion. Again, it's just like in your final project, or in the future, you're gonna do your own research. You're gonna say, okay, is that model fits the data really well, but how well? Why it's well? Okay, so look at some indexes. You need to provide the evidence. So that's a question. And yeah, and Ian provided two types of input code. That's good. Okay, both M+ and R. So in M+, that's a title and the data file. Okay, the data file variables. We have 3 variables, and we are going to use all of these. Use variable these 3. And the model, actually, yeah. So model math on HE. So if you look at this part, math is the dependent variable, is regressed on HE. Okay, so this inference, this indicated that we needed to estimate the B here. And HE is regressed on ME. So this is the second equation. And of course, if you want, you can just include the variance of ME, HE, and the math part. But default, actually, by default, M+ also provide those various parts. And yeah, she also want to have some options of the output. Okay, those are options. For example, standardized coefficient and model indexes, okay, residuals, something like that. That's for M+. And for R, she also provided the input code. We are going to use a library, SEM, and the working directory. And this is our data file. By using reader table, okay, we input our data into R and check the data. Okay. And this is a sample covariance matrix S by using COV. And the model specification, okay, so this is our model from ME to HE. Okay, this is one path. Of course, she didn't use A and B, but that's okay. She used B1 and B2. And from HE, from home environment to math is B2. Okay, and we have some variance part and the variance of the residual part. And by using SEM function inside the SEM package, so we have the M1 model and the summary, and look at the indexes. So that is output here. The output from M+. This is output from R. Yeah, and the parameter estimates here. And here, okay, so she summarized all the results by using one table here. This is really good. Okay, it's very easy for us to look at both sets of results by using M+. What is the likelihood value? Okay, degrees freedom, p-value, chi-square, okay, GFI. Some software, for example, some are not provided by M+. Okay, some indexes are not provided here. And for R, they provide all of these. Okay. And yeah. Okay. And also the parameter estimates. So we have 2 software. So the estimate, okay, V1, the estimate from ME to HE, the estimate here, the standard error here, the p-value here, and for R, also they just try to provide the values to do some comparison. Okay, this value is really close to this value, a standard error, p-value, And the B2 from HE to math. Okay, estimate the variance of ME here, the variance of HE here, the variance of the residual of the math here. Yeah, so that's a summary table. Okay. And the explanation, yes, question.
So we have to include the covariance between each variable, right?
Covariant of what? There's no covariant in that model. In this
No,
model,
I'm sorry, the variance between each model. I mean each variable.
yeah, but some of variance are by default included in the output. But if you really want to specifically include that one, just put that name in M plus,
right,
and also in R if you want to use R. Yeah,
okay.
There's no covariance in that model.
Yeah,
Yes.
I meant
Yeah.
variance, not covariance.
Okay, yes, you're right. Yeah, yes. And yeah, she just reported the value here, the standard error here, the p-value here, and this explanation. 1 unit increase in mother's education is associated with 0.139 unit increase in home environment. And also for B2, yeah, the variance part, variance of S1, standard error, the variance of ME, variance of HE, the variance of the, oh, actually, you know what? This is the variance of the residual of the children's math achievement, not the variance of the children's math achievement. This is not correct. Okay, that's the variance of the residual of the math achievement, and the model fit and why. So she said it's a poor fit. Okay, it didn't fit the data well. Why? Okay, so just list the goodness of fit. Okay, GFI, adjusted GFI. Okay, and the NFI, NFI, and NFI, CFI. Okay, so all of these are not high enough. Okay, so in the class we said, okay, closer to 1 means better. But how to close to 1? Usually we compare it with 0.95. Usually, okay. If that value, for example, CFI or NFI is close to, for example, close 0.8, we don't think that's a good model fit indexes. That number should be above 0.9. And if it's larger than 0.95, then it's good. But of course, this is okay. How can I say that? For some very special case, those rules might not work. So we have some research papers. Okay, in general, we can use this kind of like rules to do the comparison. But actually, in some very special case, this case might not work. But yeah, for general case, you can just report those numbers. And for RMSEA, we say that, okay, closer to 0 means that is the good model. But how to close 0? If you have 0.12, almost a 0.2, no, that's not close to 0, okay? You should have a number which is less than 0.05 or 0.08. If it's less than if it's larger than 0.1, usually we don't think that's a good model, okay?
Is that standard? Because I noticed in the slides you were mentioning certain thresholds.
Yeah, generally those are kind of like a reference for you to tell if it's not good, it's a good model or not good model, but not always true. Yeah, but you can just stick on the general.
But if you've got 5 models and 0.1 is your closest to 0 out of all of them, that would be your better model.
Yeah, so if you have some limit, if you have some numbers for you to choose, you have no other choice, then you're gonna choose the best one among those 5. Okay. But that doesn't indicate that the best the chosen one is the best one, because you may have some other really good model. Yeah.
Yes, ma'am.
Yeah. Okay. So that's homework 4. Yeah. So actually, I really like this table. Summarize all of these results from both M plus and R. Yeah, some of you didn't get a 4 correct, didn't get 10 points for homework 4. That's still okay. Okay, so there's some small mistakes, but if you didn't provide the correct code in the first step, then please redo it, okay? Because yeah, otherwise the score is really low. Okay, so that's for homework 4. Question for homework 3 and 4.
No.
Okay, good. So let's move forward to our mediation. Okay. So previously we have a simple example. We have 3 variables. We have mediation analysis. Now let's look at another example. The data set is called active data. Actually, it's short for advanced cognitive training for independent and vital elderly. Okay, it's quite old data. It's very traditional data. It collected from multi-site and a randomized controlled trial. Okay, and in total we have 6 sites. Okay, the University of Alabama at the Birmingham. Okay, the Indiana University, Johns Hopkins. Okay, so all of these are sites. So what's the goal? Actually, the primary aim of this trial, of this experiment, is to test the effects of 3 cognitive interventions. Of course, those are measures of cognitively demanding daily activities. So which 3? Memory test and reasoning ability, speed of processing scale ability. Okay, so we have 3 cognitive abilities to be tested. And because based on some literature, so those interventions are found to be successfully improving elders' performance on basic measures of cognition under laboratory or small-scale field conditions. Okay. And include a lot of trainings, some booster trainings, a lot of training. Okay, trainings consist of an initial series of group sessions followed by 4 sessions booster trainings at 1 and 3 years. Okay, so in total we have 5 trainings, and they are also a control group. Okay. So basically, how to describe the data set? It's very big. It's a huge data set. So in total, we have 2,832 old adults enrolled in the very beginning. That is a sample size, but some data points are not quite useful. So 2,802 were included in the medical samples. So some of them just, yeah, maybe due to some reasons they just dropped. And the examples, the current data set, okay, we just take a small sample from the whole data set. So we have 1,114 participants, and we have 36 variables. Okay, this is a very large data set. And actually, some of them are measured 6 times. Okay, and the baseline, the very beginning, they measured a lot of tests for each participant, and then we have some training. Okay, and we measured again, and then we have some other boost trainings, so 3 to 6 measures yearly. Let's look at those variables. There are 36 variables in total. So we have group variable, which indicates that the training or not, initial training, okay, and training, the post training or not, okay. And those are not important for data analysis in our mediation analysis. And also gender, we have age, we have EDU, education years, and MMSE. So this is short for mini mental state examination and total score. Okay. So we have some other tests. Again, you get the sum score, the total score. The measures from 0 to 30, with the higher score representing better cognitive functions. Yeah, so they include only those individuals with a score of 23 or better or higher. And we also have a variable called HBLTT. Okay, this is short for Hopkins verbal learning test. This is a memory test based on literature. This test gonna get the memory ability. And of course, it measured 6 times. Okay, so we have total score of all of these measures. And this is a literature. And how, what is the test? Okay, in details, it involves a list of 12 words from 4 semantically related groups that are read by the tester. Okay, after the tester reads the words, he or she, the elder people, okay, immediately ask that person immediately asks the participants to recall as many words as possible. So this is a memory test. And we have actually HBLTT 1, 2, 3, 4 to 6 measures, 6 time points. Okay. And also we have LS. LS is short for letter series test. LS test at 1, 2. Okay, so we have 6 measures. This test assesses participants' ability to determine patterns among series of 10 to 15 letters. Okay, and also this is a literature to show the intervention of LS is significant. Okay, after practice, participants are presented with a row of letters that state a distinct patterns, and they must determine which letter would come next in the pattern from a list of 5 possible answers. Okay. And the participants are given up to 6 minutes to answer 30 items. Higher scores indicate a better performance. Okay. And of course, we have some other tests. Okay, 36 in total. So we have WS126. This is short for word series task. It's another pattern. Okay, another pattern recognition from a series of words. And LT126. LT is short for letter sets task. Okay, and also it's about yeah, so this is the details of this test. And the higher score indicates better performance. And the EPT, okay, EPT is short for everyday problems test. This is our dependent variable. Okay, we're trying to improve the elder person's everyday problem solving ability. So usually we use the EPT as our dependent variable. And the previous, those are kind of like intervention or the causal variables. And this was used as a measure of a participant's ability to reason and solve problems associated with daily living. Okay, so we have some activities. Okay. So based on the description of all of these variables, we can tell that HVLTT, okay, is a measure of memory test, memory ability test. LS, WS, LS, LT, those are kind of like reasoning ability tests. Okay. So all of these kind of a reasoning to try to recognize a pattern and to say what's the next letter or other word. And because we have so many measures, it's a longitudinal, but currently we are going to look at the mediation. We don't need to look at the longitudinal data. So we just focus on the first measure. Okay, so the first measure of HBLTT is the first measure of WS, LS, LT, and the EPT. Okay. And also, we are going to look at the age inference and education's inference on the EPT. So, age, okay, is that older, with a larger age number, have a higher score or lower score? Okay, education level. So, how many years? Okay, so how many years of the person get educated? So, is that number gonna influence the person's everyday problem setting? That's our variables we are going to use in our mediation analysis. So those variables may influence the EPT directly or indirectly through the memory or reasoning ability. So in this statement, we can see that there are some mediators, memory ability or reasoning ability. So age and education are these, they directly influence the EPT, everyday problems test, or indirectly through those memory and reasoning abilities. So basically that's our model. We're trying to test this model. Age, the participant's age, and EDU, the participant's educational level. Okay, so how many years they got education. And this is a memory ability. And these three are reasoning ability, the WS, LS, LT. Of course, we focus on the first wave of data. So it's LT1, LS1, WS1, HBLTT1, EPT1. Finally, this is a dependent variable. So of course, age gonna influence the EPT. With different age, the person's daily problem solving ability will be different. The education level will directly influence EPT. But is there any mediation effect, okay, through memory, through WS, through LS or LT? Is there any mediation effect or not? That's our goal, okay? That's our question. Okay, based on this model, let's try to figure out some numbers. First, how many observed variables in this model? How many observed variables? 7. Good. Then what is the number of information? Do you still remember the formula to calculate the number of information? Oh, where the markers are? Okay, P is 7. So what is the number of information? What is the formula? Oh, this is not good. P times P plus 1 divided by 2. I'm waiting for your marker. Thank you. Just one. Thank you.
Lucky my girls next door.
Okay, so this is the formula. P times P plus 1 divided by 2. Okay. Good, excellent. Now P is 7. P is 7. 7 times 8 divided by 2. 28. That's our number of information. So what does that mean? This means in this model, I can estimate at the most 28 parameters. That's it. In that case, the degrees freedom is 0. I cannot estimate 29 or 30 parameters. That's not allowed because the number of information in this model is 28. That's it. Of course, you can estimate 27 or 26 parameters with some actual degrees freedom, but at most 28. Now, how many parameters in this model? In this model, how many parameters? Suppose we are going to investigate all of these possible mediation, all the possible mediation effects. So how many parameters? Let's count, okay? So let's just start from, actually I already gave you some numbers here. This is the P1, okay? Starting from P1, this is the inference from age to EPT. And we have Where's P2? Yeah, P2, P3, 3, 4, 5, 6, 6, 7, which is 7? This is 7, 8, 9, 10, 11, 12, 13 from here to here, 14 from here to here, 15 from here to here. That's it. I think we are going to investigate, we are going to look at these 15 coefficients. Those are single-headed arrows, 15 coefficients. And in addition to those, we need to look at the variance of age, variance of EDU, covariance between them, because these two are independent variables. We need to look at the association between these two. Variance of a residual of HVLTT, because in this part, this is a dependent variable. So we need to look at the variance of the residual of this variable. Also, the variance of the residual of this variable, or variance of residual of this variable. So how many variance parts? Variance. So we have 7, because we have 7. And the covariance, we have 1. Okay, 1 covariance. Those are coefficients. Those are P. Okay, so coefficients. So I think that's it. So in total, what's the number? What's the number? Number of parameters? 23. Okay. So how many parameters? 23. Now let me ask you, what is the degrees freedom for this model? Wi-Fi?
28 minus 23.
Exactly. Yeah. So we have 28 number of information. At most, I can estimate 28 parameters. Now I'm going to estimate the 23 parameters in this model. I still have 5 degrees of freedom. That's my freedom. I can estimate 5 more parameters, but based on this model, it's not necessary. Okay, so I just want to get the estimation of 23 parameters. Okay, that's exercise. Okay, so we actually reviewed that. Now let's look at the R code. We use SEM package. So let's look at the beginning part. So this is the second example of mediation analysis. The data is called active data. You can download it from ELC. Okay, so I have already uploaded everything to ELC. We have header, and we are going to use those 7 variables. In the original data set, it includes a lot of variables. I don't want to use all of them in this model. I'm gonna use some subset. Okay, so this is a basic operation in R. Okay, we have the review. If you want to pick some variables from the original data set, you can use that. Okay, you see, I'm gonna pick age, I'm gonna pick EDU, HVLTT1, WS1, LS1, LT1, EPT1, those 7 variables from the original data set. And then I'm gonna make a very small data set. Okay, this is data for R. The original data set is too big. I'm gonna pick some of them for this model only. So I use a bracket. Do you remember brackets? You can pick some specific rows, some specific columns, okay? So I'm gonna pick those columns or those variables. And that's our data. We call it data for R. And this is our model. So from here to here, from specified model to the pound sign, all of these tell us which parameters we are going to estimate. P1, P2, P3, okay, to P15. All of these are listed here. For example, P1, what is P1? P1 is a coefficient from age to EPT1. Okay, it is a direct effect from age to EPT1. Direct effect. I would like to know that direct effect. And look at H to HVLTT1, P2. Okay, P2 is from H to HVLTT1. That is one part of the mediation of HVLTT. Okay, this is kind of like a path. So from H to HVLTT1 and then go to EPT. This is one part of the mediation or indirect effects. I would like to know this path. This is P2, okay. And also we have P3, for example, what's P3? From H to WS1, from H to WS1. So this is the indirect effect. So I would like to know this path. This is the P3. Of course, we also want to know the P13, okay. This is indirect effect of WS1, okay. This gonna mediate the mediate the effect from H to EPT. Okay, so all of these pathways or parameters are listed here, are indicated here, from 1 to 15. And then we have the variance part, okay? H, the variance of the H S1. H EDU, the covariance between H and EDU, covariance S1, 2, we name it S1, 2. EDU, the variance of education, okay, S2. HVLTT1, okay, S3. WS1, S3. LS1, okay, LT1, EPT. So we have 7 variances and 1 covariance. This is 1 covariance. 7 variances. So in total, we have 8 variance and covariance components. 8 plus 15. So we have 23 parameters in this model. That's our model. And the next step, we are going to look at the mediation effects. So we use a BMEM package. We use several tests. Okay, so we have data ready. That is our data. This is our model, the second example of mediation. And we are going to test the effects. Actually, this is quite flexible. You can test a lot of like a mediation tests here. You can add some more terms, or you can just focus on one term. For example, okay, so look at this P6. P6, which one is P6? Let's check here. P6, EDU to HVLT. Okay, so this is P6. From EDU education level to HVLTT, the memory test. So we're gonna see if the educational level gonna influence the memory ability. And the test P11. P11 is here. From memory ability to WS1. The memory ability gonna influence your reasoning ability. Okay, what is this strength? The coefficient strength here. And the P13. P13 is here. Okay, from your one of your reasonability gonna influence your final EPT scores. So these actually test a mediation path from here to here to here. Okay, so suppose if this is significant, we can say that the mediation effect of this path is significant. Or you can say that the HVLTT or WS is a mediator between these two variables. And to test if it's complete or not, you can also test this path, if this is 0 or not, significant or not, okay? And of course, we can also look at this part. What is this part, okay? P2 times P12, P2 is this P2 times P12. That is a mediation from the H to HVLTT to EDE, to EPT. That indirect effect, that's one component. And we have another component, P2, P11, P13. Okay, this is another component. And P3, P13. Okay, P3 here. This is this component. And the P4, P14. Okay, P4, P14. This component. And P5, okay, this component. You got the sum. This sum actually is the total mediation effect from H to EPT. from H to EPT, you just specified each possible, all the possible path here, okay? You can include all the components. Add them together is a total indirect effect, total mediation effect. Of course, in this case, you have so many mediators. All of these are possible mediators, but add them together, you can see that, okay? From H to EPT, there is a significant, or there's no significant, okay, depends on your p-value. There is or not, there's no significant mediation effect from H to EPT. And you can also look at the P1, if it's significant or not, to check if those are complete mediators or partial mediators. And same thing, you can also check the path, the possible mediation effect from EDU to EPT, okay? So you're gonna check all of these possible components. And by using summary, we're gonna check the final result. That is explanation of this model. Yeah, any question? Any questions so far? Nothing new. We just add more variables into this model and give the specific path or variance based on this model. And then add some components together. That's it. It's still a mediation analysis, but it's more complicated than the previous example. Any question so far? Good. Okay. Yeah, so this is just the same model I just repeat. Okay, repeat I should use this one. Yeah, because here we can clearly tell the path. Okay, P2 times P12, that part, and the P2 times P11 times P13, the coefficient between these. Yeah, so those are detailed numbers, detailed paths. Okay, so run, and you have a bunch of outputs. Okay, this is one of them. So we have all parameters estimates here. Those are point estimates. Standard errors. Okay, z-scores, p-values. Okay, from P1 to P15, and variance, covariance, all of these are variance part. Okay, and also these are effects. We include two components in the effects part. This is the two. Okay, this is the total mediation effect from H to EPT. So get the sum of all these components. Finally, the estimate is here. This is the sum of all possible mediation effects from H to EPT. That's it. This is the sum. This is the standard error. Of course, okay, so because it's so long, I just truncated, but actually this means it's one component, okay? And standard error here, and the z-score or the t-ratio here, and the p-value here. Based on this component, what's your conclusion? Is there any mediation effects? Yes. Why? Significant. Yes, because this is a value, this is a p-value, it's really close to 0. It is significant. So from H to EPT, yes, memory ability and those reasoning abilities did mediate the effects. And let me ask you, are those complete mediator or not? So we should go back to this path. First, so first step, okay, there is a mediation effect through those variables. The second step is that complete mediation or partial mediation. Which path we should focus on to answer this question? Which path?
P1.
Yes, P1. We're gonna check if P1 is significant or not. If it is significant, what's your conclusion? Complete or partial? Complete or partial? Agree? Agree?
Sure.
Okay, yeah, it is partial. If it's not significant, then It's complete. Yes. Okay, let's check.
50-50 chance.
Let's check P1. P1. Let's look at number. What's the number? What's the p-value? Based on the
5.3.
scientific. If we read the normal way, what is the p-value?
Oh,
This is a scientific way to record a really small number. But if you translate it to the usual, the normal way, what is the p-value?
0.0537. 0.0.
0.05 or 0.5?
Well, you move it just one spot, so it'd be 0.5.
Exactly, 0.5.
1.
Is that significant or not?
No.
Then what's your conclusion? It's complete, yeah. So from H to EPT, there's no significant direct effect. Actually, the age influences people's memory and the reasonability so that the EPT is changed. It's not directly from age to EPT. Actually, through memory and the reasonability. Those are really important mediators. Yeah, that's a part of the in conclusion that we can put. And let's look at the second component. P6, P11, P13. What is this part? Okay, let's look at this. P6, P11, P13. Okay, then it's from education. We want to know the specific mediation path, not the total, not the sum. For this specific 6, okay, education level to HVLTT to WS to EPT. Let's look at the, okay, so let's look at the, what's the meaning of this path actually? What's the meaning of this path? That means the education level gonna directly influence the people's memory ability. And as a memory ability gonna influence the people's WS. What is WS? It's a word series, something like that. Okay, it's one of the reasonability. Gonna influence this test, and this test gonna influence people's EPT, the everyday problem solving test. If this significant or not. So based on this output table, please let me know if it's significant or not. Yes, because the p-value is very small. This is the p-value, okay? It is significant. Okay, so the educational level indeed gonna significantly influence the people's memory ability and the influence the reasonability and the EPT value. There's another problem. Okay, so let's look at this sign with the direction. It's negative. This is positive. So what does it mean? Can you explain why it's negative? Negative is a sum of all the mediation effects from age, which influence the effect from age to EPT. So why it's negative?
As you get older, those skills
Exactly. It's negative. With a larger number in age, with older, yeah, then the ability got decreased. But how about this one? This is positive.
increase in education indicates an increase in other.
Exactly. The higher level of the education, the higher number in the education level, the higher score in the EPT part. Okay.
So I can blame my age. Awesome.
Okay, so we can also check the model fit. Okay, that's just a model estimate, but is this a good model or not? Okay, we have some, yeah. And let's use the degrees freedom. Yeah, it is 5. It is 5. We just calculated it's 5. Okay, we just calculated it should be 5, and it is 5. And then let's look at the whether I didn't copy the results. Let me see. I didn't copy the results, and let's just do it. Let's just do it now. Check the model fit. So go to R, please go to R Studio. Of course, you need to download the R code and the data file from PLC. And open and save it to your local directory and open that file from your R Studio. It's called active. The data file is called active. Oh, this is the data file. Okay, this is data file. The R code is called mediation 2. Okay, mediation 2 is a code. And of course, we need to change the session set working directly to our local folder. And we're gonna use SEM package, also the DM package. Yeah, let's just load in these packages. The reader table, the data file is called active.txt. So read the table into R. We can check the original data set. Okay, you can see that this is a huge data set. We have so many variables. You know, group training, gender, age, ETU, okay. HBLTT 1 and 2 and 3 and 4 and 5, 6. Okay, 6 waves. So we are going to use the first wave of the data. Yeah, so just take some of the variables into the original one. And this is a smaller data set. We are going to focus on this data set, which is much smaller, which has 7 variables. 7 variables only. And then specify model part. Please try to highlight all of these. Okay, this is just one block. You're gonna highlight all of these, starting from the specification, okay, to the pound sign, and run them together as a one function. That's it. And we can, yeah. Here, I provide you different choices of effects. Actually, it's very flexible. You can just put any kind of like effects here. You can check this compose the total mediation effect from age to EPT or some specific mediation effect. Or you can check this one. Okay, so you can just change the path here. Suppose we are going to look at the first effects and we use a support test. Okay. And that's the estimate of fairness. And we can also use summary to look at the results. Okay, summary. Oh yeah, it is that's it. Okay, that's it. There's no more model fit indexes. That's it. We only have AIC, BIC. We don't have any other. So let's try to do this. We'll see. We don't. Okay, yeah. You're gonna use the model fit indexes. Make it available. Then we have a lot of like model fit indexes. Please tell me if this is a good model or not, based on the results here.
No.
You're right. Actually, it's not good model. Yeah. it's, yeah, by looking at those numbers. Okay, GFI 0.7, AGFI, okay, negative 0.4, RMSEA 0.5. None of them are good, okay? NFI, MLFI, and CFI, RMI, none of them is good. Yeah, question.
So is the Tucker-Lewis index and Tucker-Lewis NNFI the same thing?
No, this is for normal. This is for non-normal.
Okay.
Yeah, yeah. Anyway, based on the model fit, actually, this is not good model fit because this is not good model. So we're gonna improve. Next semester, I'm gonna show you how to improve the current model. We have a lot of suggestions. We're gonna have a lot of like pieces, ways, a lot of like a path or trick something. But for this semester, just assume that this is a mediation model. We're trying to do the test, okay, although it's not good. Okay. That's for M plus. That's for M plus. Although it's not good model, it's not good model. That means, okay, those assumptions may be not reasonable, okay. But still, we can do the test of the mediation. So yeah, we're gonna improve it. We're gonna improve the model next semester to make it to make the model fit better, to make it more reasonable. Okay. Where's it? For example, maybe next semester after we talk about the fact analysis, we're gonna combine these three as a fact model. We're gonna look at the latent variable first. It's reasonability, and that variable is measured by these three tests. Okay, so we're gonna make this model better and better. But that's for fact model. That's for next semester. But so far, yeah, we just look at the observed variables only. And that's our code. Okay. Any question for this part? Any question for this part? Oh, wait a minute. We didn't check. Okay, wait a minute. We didn't check the mediation. So yeah, this is our code. I'm sorry, our code. I'm confused with the M plus. M plus gonna show you all the possible mediations. So that's R. R, we need to specify this component by ourselves. Okay, but M plus gonna will just show you a lot of like mediations and indirect effects. Any question? Any question? Okay, then let's move to M plus. The same path diagram, and then we are going to use M plus code to understand, okay, to translate this model. Title data, we use a different file. Okay, so it's called M plus CQS data. So it's the same data set without the first row, without the header, because in R, we would like to know the column names. But here in the M plus or EQS, no title, no variable names. So that is the same data set without the first row. Okay. So the variables in that file. So those are 7 variables. We are going to use all of them. Okay, all of them. You can also use the original data set. You can list all the 36 variables here in the first row for names. And for the second row, for use names, you have to pick these 7 useful variables. That's a difference. But for that data set, I already make it small. I already make the data set set with 7 variables. Okay. Model. Look at this part. You don't need to specify 23 parameters in M plus. That's it. This is our code, which much similar than our code. What does that mean? Okay, HBLTT1 on age and edu. What does that mean? HBLTT is regressed on these 2 independent variables. Actually here, it included two coefficients, P2 and P6 has been included here, okay? WS1 on H, EDU, HVLTT1. These tell us another model, regression model, multiple regression model. So this is a dependent variable. This is regressed on H, EDU, and HVLTT1. Actually, this statement included the coefficient of P3, P7, and P11. There are three coefficients. LS here on H and EDU. LT1 on H and EDU. EPT, let's look at the EPT. EPT is the final dependent variable. Okay, on H, okay, so we have this path. On EDU, we have this path. On HVLTT1, we have that path, P12. WS1, we have this path, we have this path, we have this path, okay? EPT, regressed all, EPT is regressed all of these 6 variables. Yeah. And let's look at this part. H, just a name, means I'm gonna investigate as a variance of H. EDU, I'm gonna investigate as a variance of EDU. H with EDU, I'm gonna investigate as a covariance between H and EDU. So 3 parts, variance, covariance. Okay. That's for the model part, done. That's it, for the model, done. It's very clean, okay, very neat. But as we needed to investigate the mediation effects, we needed to make this option available, model indirect. Model indirect, what kind of like mediation effect we would like to investigate? EPT IND H. EPT IND H. Do you still remember? IND and the VIA, the difference, the usage of these two. Yeah, so IND, VIA. So we have different paths or different possible mediations. Okay, so EPT IND H. So that means please provide all the indirect effects from H to EPT. Okay, H is independent variable. EPT is a dependent variable. IND, indirect effect from H to EPT. All the possible mediation effect. Please list all of them. Okay, that's a meaning of the first statement. But if we have specific paths, for example, EPT is a dependent variable, IND indirect effect from H to HVLTT to WS1. Then that's a specific path from H to HVLTT to WS to EPT1. That is a path we just investigated before. From here to here to here to here. That is a specific indirect effect. Yeah. But if we didn't give if we don't give the mediators between the independent variable and the dependent variable, so we will just provide all possible mediation effects. And also we can use VIA. Okay, so this statement will give the all paths, okay, from H to EPT through WS1 via WS1 through WS1. Okay, so different statements means different mediation effects. Okay. Okay, so after we run the code in M+, we have a lot of like tables. This is one table called the model results. Okay, so all the results are listed here. HVLTT on H and EDU. Okay, those two paths. WS on H, EDU, and HVLTT. Okay, the path here. LS on these two, LT on these two. Okay. And also we have EPT on. Yeah, EPT on those 6 variables. So we have these passes. Estimate standard error, t-value, and the t-value. And of course, M plus provided the mean part, the intercept part. And we have the residual variance, the residual variance of HVLTT1, okay, HVLTT1, WS1, LS1, LT1, EPT1. Okay. Those are residual variance, okay, because those are dependent variables in our model. And we have the mediation effects. Let's look at the last part of the M plus output. Okay, we have total indirect, specific indirect, and direct effects. So all the mediation effects have been listed here. So let's from the very beginning part. Okay, total from age to EPT, from age to EPT. Total is negative 0.144. We just calculated in R, right? You remember that we calculated all the, oh, wait a minute. That's for total indirect. Okay, that's a total. Indirect plus direct. Let's look at the total indirect. Negative 0.158. That is the total mediation, total indirect effect. Standard error ratio p-value. And then we have specific indirect. What is a specific indirect? For example, here, from age to HVLTT1 to EPT, okay? From here to here to here, this is one possible component. That specific indirect or mediation effect is negative 0.033. Standard error ratio p-value. Or HWS EPT1, okay, from H to WS to EPT, this is another component. That specific indirect is estimated here. And we have this one from H to LS to EPT. And this one from H to LT to EPT. And this one from H to HVLTT to WS to EPT, okay? So this specific is estimated here. So from here to here, all of these are specific mediation effect or specific indirect effects. If you add all of these components, okay, we have 5 components. If you have, okay, the sum of these 5 components, that's it. The total indirect, that's it. And of course, finally, we have direct effect. This is P1, this is P1, okay? P1 from H to EPT. And the p-value is 0.5, it's not significant. Okay, so that is the H part. Okay, so we have total indirect. We can go back to check, okay? These numbers should be the same as the previous total indirect effect in R. Okay, let's remember, let's remember these numbers. Negative, okay, negative 0.158. Okay, let's go back to check. It's here. Yeah, it's here. It's just this number. Negative. I'm sorry, I needed to move the cursor. Okay, negative 0.158. If you round it up, it's just 158. Okay. And it's significant, okay? The p-value is almost 0. And please check this specific one. This is a P6. This is a specific from PDU to P. It's not the same. And the P1 is estimated here. Okay, this is the P1 direct from H to EPT. P1 is 0.014. Okay, the p-value is 0.5. Let's go back to check. Yes, if you round it up, it's 0.014. And the p-value is 0.05. It's not significant. And that's just summarize the age part. We also have the EDU part. From EDU, we also have a lot of like mediation part. Okay, so the next page summarize the EDU part. From EDU to EPT. From EDU to EPT, we also have a lot of components through those mediators. And we have the total, we have specific, okay, total effects. This is the total effects. This is the total indirect effects from EDU to EPT. And this number is sum of all of these 5 components, okay? These are specific mediation. For example, from EDU to HBLTT to EPT, okay, this path. And also we have specific from EDU to WS to EPT, okay? From EDU to WS, this specific path. And we have this path, and we have this path. Add these 5 together. Yeah, and we have this, okay? From EDU to HBLTT to WS and to EPT. We add these 5 possible, all possible components. We have 0.5. 0.5 is our total indirect. So again, based on the M plus output here, please let me know if there's a mediation effect from EDU to EPT. EDU, the total indirect, the total mediation. Is that significant or not? Yes, it is significant. It's 0.5. So is that complete or not? Is that complete? This is a direct effect. Okay. It's partial or complete. It's partial because it is significant. In this case, it's significant. So what does that mean? So actually, educational level significantly change the EPT's scores significantly, but the age is not significantly changed the EPT scores. In addition to the direct effects, the significant direct effects, we also have some mediations, okay, to memory ability or the listenability. Those are also significant, okay, because the p-value is almost 0. So educational level gonna influence the memory ability, and also those tests. Those are listenability tests. Okay. So the higher education level, is a higher score in the EPT test. Okay, so that's M plus. Any question? So we just verify. Oh, we can also check this specific, okay, because in R we check this specific path. So from EDU P6 times P11 times P13. So this is estimated in M plus as 0.031, and it is significant. Let's go back to check R. Yes, okay. It is 0.031. Okay, and it's significant. Yeah, that is a specific indirect effect. It's a same, and that's positive. It's positive. Okay. So either use R or M plus, you will have the same conclusion. Okay, because the data set is the same, the model is the same. Any question? Question? Then let's have a break. Okay, let's have a break, and the next we're gonna continue EQS and AMOS, and then we will look at the moderation. Okay, yeah. Let's have a 15 minutes break. Yes, yeah.
For the homework, for the
yeah.
variance,
Yeah.
you're looking for the standardized coefficients for the associations.
What do you mean? So what's a standardized association? What is that? There's no standardized association because you're gonna report the variance and the estimate and the standard error and the p-values and the z-value. Yeah.
The 12th estimate.
Yeah, yeah. So those are
Oh, don't use a standardized version. You can just use the original raw version. Yeah,
This
please.
one?
Yes, yeah.
So this would be considered unstandardized, right?
This is
Yeah,
a
okay.
raw, yeah, this is unstandardized, yeah. Because we have so many ways, we have 3 ways to standardize your data.
Right,
You're gonna specify which way you standardize your data.
right,
It makes the problem complicated.
right.
Just report the original one.
Okay.
Yeah.
Thank you. And so. So, yeah. I know that's right. Also, is it
Yes.
okay if we round up as well?
Yeah, you can run it up to 2 decimal points or 3 decimal points. Yeah, that's okay. Yeah.
Thank you.
Yeah.
Did you say you had your contract?
Yeah.
Okay.
It's just that's.
Oh, yeah. Okay, so then 2 for the.
Congratulations.
Thank you. You too. Thank you. I'm glad that's out of my head. So which our lips from is?
Those are, yes.
Yeah.
The national stuff. Dissertation. We don't have to do, because when we came in, I thought we had to be publishable first, but we apparently don't. So, I think it's all, anyway, as long as we get something done. Yeah. So, what about for you?
So next semester is the perspective.
That's what, respect. That's it. Would exceed.
So I have to defend that, which I already have my dissertation, because I'm doing the manuscript side.
Okay.
So I have 2 chapters. I'm done just rearranging some data, drop some stuff, try to push some stuff, and some drawing I like it. So I have 2 chapters, just another, I add on my 3rd chapter and figure out how I'm going to. I have an idea of what I'm going to do, but as far as the execution, still think about that. So, me and my body haven't talked about it as much because I think this is a lot of after get some time to relax a little bit. And Dean is to keep the ground running. So she has me like, okay, now perspectives. Because I think I have fitness. So yeah.
What is your research focus
So my research focuses on how we structure our language and structure things within context. So, I mean, I was down to virtuous. So, but not necessarily because they're more of a linguistic style. So, what I propose for one of my theory papers that I'm using the abstraction methods is that so how we structure our language, so the knowledge that we have about certain concepts influences how we structure our messages or how we produce our messages. And that has an effect on how the recipient conveys the message. So if I come to you and have a frame,
Right, it's context of it all.
yeah. So I come to you as a frame, you give me a very specific submit, I evaluate it as a supportive frame. But you said saying that you see a romantic partner, and it's a way to give a situation, your personality traits influences how they evaluate it. Because if I'm a high sensation seeker, then if I get from a very high sensation seeker, then I may act on whether the advice that they give.
I like that. I didn't see anyone on your Zoom.
He's not, that person is not here. It's just me. Maybe we can, maybe I can just close that. He's left. Yeah.
I looked a while ago. So I was peeking around the corner. But I got it recorded.
Okay.
So if they need to watch it, have them contact me.
There's no one there. Just me.
If I feel like I don't see it,
Okay. Let's just get started. So we learned R code, we learned the M plus. Yes, so let's look at EQS. Same thing, EQS, you have to prepare the input code. And just like EQS, just like M plus, this part, the equation part is really simple. You don't need to specify each component just like in R. So yeah, in the very beginning part of title, specification, 7 variables, okay, number of cases, okay, sample size, 1,114, data set, method, matrix, variables, you're gonna rename your variables into by using V, okay? V1, V2 to V7, equation, that's it, okay? Just like M plus code, HBLTT1 is regressed on by these two, regressed on H and ED. Of course, we have the residual part. WS1 is regressed on these 3. Okay, WS1 regressed on these 3 variables, and we have the residual part. LS1 is regressed on these 2. LIT1 is regressed on these 2. EPT is regressed on all of these 6 variables. Okay, and that's it. And we have the residual part. So that's a model, or that's the equation part. And the variances, we're gonna estimate all of these variances. Okay. Residual 1, 2, 3, 4, 5. Okay, so variance of all of these residuals, covariance between these two, the H and ED. And then print effects. Yes, effects means mediation effects. Mediation effects, yes. Okay, so that's a code. That's output. We have coefficients estimated. Okay, coefficient for V1, V2, and standard errors, significance. All of these coefficients are listed here. This is the full equation. Okay, yeah, all of these coefficients, standard errors, ratio, value. And for Amos, okay, that's for EQS. Okay, that's for EQS. For Amos, and you have to draw the path diagram. Actually, this is from Amos. This is from Amos. And this is the original model. This is estimated model with those numbers. Okay, the estimates are attached in this path diagram. This is a variance of the residual of EPT1, E5. This is also variance of E4, variance and covariance here. Variance of H, variance of ED, that's our coefficients. Yeah, that's Amos estimates. And just like in our simple case, if you want to check the mediation effects, you need to check the box, okay, indirect effects. In that box, after you check that one, you have the report for total effects, direct effects, indirect effects, mediation part. But again, those are for numbers, just point estimate. No p-value, no confidence interval. If you want to check the significance of all of these effects, you need to run the bootstrap mapping. Okay, not bootstrap mapping. Okay. Bootstrap resembling method, and they will provide the bootstrap standard deviation, standard errors, and to check if it's significant or not. That's for the first question. Yeah. Any question? Any question for the mediation? Okay, so let's look at the other. The other model, moderation analysis. So this is mediation. We just finished talking about this part, okay? And next, we're gonna look at the moderation. And of course, we have some examples. And we're gonna focus on the interaction part. Moderation analysis, actually it is an interaction analysis. Interaction term is a key term. And we can combine these two models, mediation and moderation, to have some hybrid models. Okay, moderation. Again, we start from a really simple case. Just two variables, x and y, same as before. Okay, simple regression. X gonna causes y. And the coefficient here is marked as C. Okay, we can look at the C if it's significant or not, and to see if the inference of x and y is significant or not. So the equation is like this. Y, the dependent variable, is coefficient times C, times x plus E. Of course, we have already sent it as data, so there's a no intercept part. That's a simple linear version. And now let's make this case a little bit complicated. We have another variable, third variable, Z. For example, Z is gender. We have two groups, female and male. Okay, Z could have 0. Z could be 1, could be 0. For different group, the coefficient here might be different. So, for example, the same model is the same data, but different groups of same model, but different groups of data. For example, so for male students, the coefficient becomes A. Okay, so X gonna inference Y, the coefficient is A. But for female, when Z equals 1, for female students, the coefficient is B. Okay, so Y is B times X plus the residual. For the males group, Y is A times X plus E plus the residual part. Now we would like to know if these two, A and B, is the same or not. If it's not, if it's different, A and B are significantly different, then we're gonna say the Z value, the Z, okay? In this case, we have two values. We say that is a moderator. Z change the coefficient from X to Y, okay? So previously we don't have Z variable involved, but after introducing this variable, then the coefficient might be different for different groups of data. So if A and B are different, we would say that gender Z moderates the relationship of training and math. In this case, the X is the training, okay, the Y is the math. So the inference of the training and math. So this is one hypothesis. So some people say that okay, male students may benefit more from training than female students. In that case, we're gonna test if gender is a moderator. if you want to do this test, then Z, gender, is a third variable. Okay. That's it. This is the definition of moderation analysis or moderator. Okay. So sometimes it's weakening. So yeah, it's up to the detailed cases. So classical moderation implies that weakening of causal effects. Moderator can also modify or even reverse that effect. Okay, it's totally depends on our detailed scenarios. And we also have a complete moderation. Okay, complete moderation will occur in a case in which the causal effects of X on Y would go to 0 when Z took some specific value. When Z picks some value, some either 0 or 1, or they pick some value, that coefficient goes to 0. Okay. Now we say that this is a complete moderation. Okay, how to conduct? Yeah, question. Yeah,
Doesn't matter if they're equally distributed on the moderator, if you have more males and females.
it doesn't matter.
Because
You
you're,
just look
you're
at no.
separating.
Yeah,
Okay.
yeah. So how to conduct the moderation analysis? Think about that. Okay, the inference of Z. Okay, on the coefficients. Actually, we are going to look at the interaction term of the original independent variable and the moderator. That's it. This is the key point. If the interaction term is significant, the coefficient is significant, then we can say that there is a moderation effect. Because if it is significant, we're gonna change the inference of the X on Y because of the Z value. And yeah, if C is not 0, then there's a moderation effect. So we're gonna check the C is significantly from 0 or not. That's our problem. We can just check the details by using the equation here. That's the equation. So we have Y, the dependent variable here. The X is the original independent variable. Z is a moderator. And the key part is check the interaction term of X and Z. So when Z is 0, again, we assume that there are 2 cases of the outcome of Z. When Z is 0, this term is disappeared. This term disappeared. So Y equals A times E. That's it. But when Z is not 0, when Z is 1, then this becomes 1. So 1 times X, UX. And the Z becomes 1, okay, it becomes B. So it equals B plus some, okay, AX plus CX. So A plus CX. Now the coefficient becomes A plus C. Originally, it's A. Now it becomes A plus C. The C is a key part. If C is significantly different, then these 2 coefficients are significantly different. So we're gonna check C. C, the coefficient of the interaction term. Yeah, and we have different cases. If C is not equal to 0, then we say that there is a moderation effect. When C is negative, okay, C is negative. So this becomes smaller than this A. So the relationship between X and Y becomes weaker when Z started from 0 to 1. Okay, when Z increase 1 unit, actually the C is negative, so the relationship becomes weaker. But when C is positive, then we add something on top of A. So this is stronger than the original X. So the relationship between X and Y becomes stronger when Z increase by 1 unit. That's it. This is our interaction analysis. But people call it the moderation analysis. Nothing fancy. Okay, we have already, if you took the regression course, we have already covered this part, interaction term. So let's have a summary. And in SEM, we may use this path diagram to show the moderation effect. Originally, we have X and Y. And this path or coefficient might be different based on the value of Z. The Z might change the coefficient here. Okay. So the moderator Z is a variable that alters the direction. Sometimes they're gonna change the direction. Originally it's positive, after take different value of Z, it becomes negative. It's a positive, okay? Or strength of the relationship between a predictor X and an outcome Y. Usually the question involving the moderators adjust where or for whom. Okay, so we need to look at the specific value of Z. Okay. And that's our path diagram in SEM. But that is just an illustration path diagram here. We're just trying to illustrate the moderation like this. This is not working path diagram. What is a working path diagram? That's it. We're gonna look at the coefficient of interaction term of the original independent variable and the moderator. That's a key part. This is a working path diagram. Okay, this is our multiple regression. Multiple regression involves the interaction term. Yeah, that's it. So you need to calculate the interaction term first. Interaction term between the original independent variable X and the moderator Z. And just run the multiple regression. That's it. Let's have a review. So interaction term. These slides I took it from the my regression course. If you took my ERSH 8320, so you should be very, very familiar with these cases. We talk about different types of interaction terms. In this case, we don't have any interaction terms between X and the T. So T is one factor, X is another factor. Both of them gonna influence Y, okay? So for different value of T, T1 to T2, these are regression coefficients. Under T1 condition, or T equals 1, this is a regression. Under T2 condition, or T equals 2, okay, the second condition or the second group, we have the other group. In this case, there's no interaction term between X and T. No, it's significant. Of course, there could be interaction term, but it's not significant. There's no significant interaction term between X and T. In this case, no significant interaction between X and T, although this looks different. Okay, the original value might be different, but still look at the slopes. They are parallel to each other. Okay, different conditions, different groups. T1 and T2, they are parallel to each other, no interaction term. But look at these two cases. T1 and T2, the regression lines are not parallel to each other. In that case, we have interaction term. Same thing in this case. Okay, the difference here is that they are here, we have intersection here, but here it's somewhere. Okay, somewhere if you can extend the X variable here, although there's a no intersection here, but still it's not parallel to each other for T1 and T2. So these two cases, we have interaction, we have significant interaction effects. Okay. Okay, so that's it. For moderation, it's quite simple, just multiple regression, but you needed to add the interaction term. That's it. Moderation analysis. Any question so far? Any question?
I have one.
Yeah.
The original diagram, the path diagram, this is under the assumption that there is a relationship in between X and Y, right? Or
Yes.
For moderation to have some type
If you don't consider Z, if Z is not there, you just consider these two. You're gonna investigate the original coefficient. Yeah. But when you consider the value of Z, by taking different value of Z, the coefficient might be different. Then there's a moderation or interaction between X and Z, because Z is gonna change the coefficient here. So Z is really important in that case. So there's a moderation effect. Yeah, moderate the effects from S1. Yeah. Any other question? Great question. Yeah. Any other question? Okay, then let's try to combine these two. we have mediation, we have moderation. Let's try to combine these two together. Moderated mediation. So that means basically that is a mediation model, but for some tests, it's can be moderated by another variable. Moderated mediation or mediated moderation. Basically, that is a moderation effect, but for some tests, we can mediate that test. Okay, so what
Yeah,
are
not
these?
confusing at all.
Okay, yeah, it's quite confusing. Let me give you some examples that it's really easy to understand those concepts. For example, this is the mediation. If I take out the O here, it is a mediation. But the path A and B could be different if we take different value of O. In that case, it is moderated mediation. So the mediation effect, originally we have mediation effect A times B. But if we have another new variable involved included in this model, this variable could change the mediation effect. For example, gender, okay, it's a very obvious case. Maybe for male, there's a mediation effect. For female, there's no mediation effect. In that case, there's a moderation effect of gender. Gender will change the mediation effects. This is called a moderated mediation. But yeah, sometimes just change this path, A only. Sometimes gonna change B, or sometimes just change both. It depends, yeah. This is one possible example. Or moderated mediation. If I cover this part, if I take out the M, this is just a moderation effect. This is interaction term. This is original X, original Y. This is a moderator. But now I'm gonna add one more variable here. The interaction coefficient might be mediated by this M. The M might mediate this direct effect from interaction term to Y. This is called a mediated moderation. So basically it's a moderation, but we add the mediation on this test. Okay. And we have some different types of path diagram to illustrate this case. Okay, so for example, this is a moderation. Okay, so if you read the paper, journal articles, or some chapters, if people show you this path diagram, that means there's a moderator. Okay, moderator Z. So from X to Z, so we have the Z between these two. So this is a moderator. Also, this is a moderator. So in order to translate the illustration path diagram to the working path diagram, you only need to do this. Okay, just get the interaction term between these two variables or these two variables, and add this as a further independent variable, and use the multiple regression. So this is a notation of the moderation effect. Okay. So if we have this illustration path diagram, what is the working path diagram? So this is a mediation, but I add a moderator here. I changed something here. Remember, this is one way to illustrate the moderation effect. This path could be moderated by this variable O. So that means the variable O can change the coefficient from M to Y. Based on this illustration path diagram, what is a working path diagram? How are we going to make it very easy for us to translate the path diagram to code? What is the working path diagram? So you have to consider the interaction term between M and O. right? Because M and O is a moderation part. So you're gonna look at the interaction term between those two variables. So finally, that's it. Originally, it's a mediation. Okay, X goes to Y and M here, mediation. But this test might be different, might be moderated by O. So you need to investigate the interaction term between M and O, the interaction term here, and the original moderator here. You're gonna check this test, MO, the interaction term, the coefficient of the interaction term. If this is a significantly different or not, okay, if this coefficient is significantly different from 0 or not. And then you can see if it's a moderated mediation or not. So this is a model we're trying to work on. Yeah. Any question? This is a translation, or you can see that this is a translation of this test model, test error variable. And we may have this case. The direct effect might be moderated by the same, the moderator here. So I use this symbol to show that this is a moderator on this path. And then how to translate it into the working path diagram, that's it. M here, okay, X here, Y here. This is the original mediation model here. But you need to investigate the interaction term between MO and XO, right? Yeah, MO here, XO here, and O is here. O should be included. And we're gonna check the interaction term of this one and this one. Yeah. Yeah. This is a second example. And of course, that O, the variable O, can also change this path. So the O can change all of these three passes in the mediation analysis. Then, yeah, you can just, yeah, you can translate this path diagram into another working path diagram, okay, by adding another term. Oh, XO is already here, but that XO should go to F in addition to go to Y, okay? Because this gonna influence the coefficient from X to M. So it's different as previous one. Okay. Question. So these are hybrid models. Hybrid models. It makes the model more and more complicated or close to our real cases. And yeah, in some cases we have some moderators in addition to mediators, or yeah, we have different cases. Question? Let's look at example. Okay, so we have all the data set. We have three variables: HE, ME, math. From here to here, it's just our old example. Okay, but now I add something new. This is a new hypothesis. Gender is a moderator in the relationship between mother's education and the children's math achievement.
So the gender of the child or the
Mother, or wait a minute, gender is child, yeah. Child, the trend of the child is a moderator in the relation between the mother's education and the children's math achievement. So it's a moderation, it's a moderated relation. Originally it's moderation test. So from mother's education to math, we have that direct path and we put the gender between. So gender gonna influence the coefficient from mother's education to math. So B2 is the most important coefficient. We're gonna check B2 is significant or not. So that's a code. Okay, so we have multiple regression. Basically, we just create a multiple regression. That's it. But here, okay, let me show you here. This is a new variable. You need to create an interaction variable. ME times gender. You create a new variable, interaction term, ME gender. And then you make this available in our original data set. The original data set with C bind, remember it's column bind. We can add another extra column or variable. C bind is the original one. Add the interaction term, we updated it to the data set. So this data set is a new data set by adding an actual column here. So the S is a covariance matrix which should based on the new updated data set with the interaction term. Okay. And we have specified our model here. So in addition to ME math, we have the interaction term with gender. So this is a multiple regression. B1 is from ME to math. B2 is from interaction term. Okay. B3 from gender to, and then we have a lot of S1 is ME, the variance here. S2, gender. S3, the interaction term variance. Residual mass S4 and the covariance. Okay, covariance between two of these three variables. Okay, we have three covariances. And that's it. This is our multiple regression. Oh yeah, this is a larger version of the previous model. That's it. The same code. Now I have the output like this. Please tell me if gender is a moderator in the relationship between mother's education and kids' math achievement. So I'm gonna show you again. So here, yeah.
So it would be because it's 1.6 to the -7, so that'd be like 0.00001.
Yes.
So
It
it's
is significant.
Yes.
Yeah. And it's negative. So I forgot which one is female, which one is male. So you need to check, okay, male or female. So yeah, so it's negative. So I don't know which one is stronger. Yeah, we need to, let me see, is there any explanation of this? No, yeah, we need to go back to check the original definition of gender. 0 means male or female. Okay. So anyway, gender is a moderator. So gender will change the mother's education influence on math. Okay. Yeah. Now let's look at our mediation model. Previously we have this mediation model, okay? ME, HE, math. Let's see gender. If gender gonna change all of these three coefficients or not. Okay. So previously we just test this one. We just test this one. And from ME to math, gender. But now we use a complete mediation model and then put the gender in all of these three tests. Yeah. This is a working diagram. Yeah, if you want to do this test, you have to use this model.
How could there be a gender between home environment and math? Explain the gender role in home environment.
Okay, so maybe for girls and boys, okay, maybe the influence of the home environment have more influence.
Okay.
Maybe for girls, I don't know. Maybe for boys, not so significant, but for girls, it's more
Sure.
likely to be influenced by the home environment. But it depends on our data. We don't have the results yet, but it just guess. Yeah. Okay, so anyway, this is our working diagram. And we need to investigate the interaction term between Yeah, this one and this one. And also this one, yeah, we find a between B7. Yeah, so that means the gender. If this is significant, what does it mean? So the gender gonna influence the path here. If this is significant, that means the gender gonna influence the path here, okay? If this is significant, that means the gender gonna influence this path, okay? So we have different focus, okay? We have different habits, 3 habits. Question. And that's our code, okay? So we translated the model here to our code here. So we have a lot of coefficients that behind so we have a lot of coefficients. Variance, covariance. Yeah, that's it. This is original mediation effect. Okay, B4 times B6. B4 times B6. And B5 times B6. B5 times B6. This is the other mediation effects. And for M plus, that's a code for the same model. If we use M plus, that is our model. So math, okay, so we have a lot of dependent or independent variables. This one. All of this should be included here. Math on all of this. HE on, okay. ME on, ME. Oh no, this is no ME on. Okay, ME is an independent variable. There's no ME on. Okay, but these are 3 variances. Okay, ME variance, ME gender variance. Okay, and covariance. All of these are covariance. A lot of covariance. Okay, covariance, a lot of them. And we're trying to look at the mediation effect. Okay, math, IMD, ME. So from math to ME, so mediation. And if you want to use inverse, then that's it. This is the path diagram. So we have math here. We have ME. This is the mediation, and we have interaction term here, And also you need to consider gender here. Okay. And the interaction term also goes to HE. Okay. In addition to goes to math. Of course, this interaction gonna go to math. And check the interaction term, the significance or not. Question?
The results.
We can do the exercise.
Oh,
Yeah, this is the output. Okay, so for Amos, that's the output. But Amos, we didn't tell if it's significant or not. So just give your number. There's no p-value. Yeah, and here, okay, here we have the p-value. P-value, for example, this is a p-value for interaction term to HE. Let's look at this part. This is not significant, okay? So gender will not change the path from ME to HE. If we just look at this path, 0.059, gender will not change the coefficient from ME to HE. Mother's education will not be influenced. Mother's education on the whole environment will not be influenced by kids' gender. So that's a conclusion based on that. And you can also look at this one. This is significant, okay? Gender will change the influence the relation between ME and the math. Okay. And also gender will not change the coefficient from HE to math. So girls and boys are the same. No significant difference between girls and boys. Yeah, it's not significant. Yeah, based on the data here. Yeah, that's
Sometimes you have to
interesting.
check it just to see.
That's good, yeah. Okay, any question? Then you will have homework 5. Okay, homework 5 is very simple. Mediation model. We covered the mediation, moderation, and hybrids. Okay, for mediation model, just write your understanding of this part. So including, but you have to include in the goals. Why do we have to investigate the mediation model? What's the goal? Okay, and the basic path diagram. You can use a 3 variable version because mediation could be really, really complicated. Just use a basic path diagram to show your mediation and model equations. Show me your equations. In mediation, we have 2 equations. Okay, we have 2 equations. Of course, you should use a coefficient, one set of the variable. The variable coefficient and assumptions. Yeah, what kind of assumption do you assume for the mediation?
Do you want us
model?
to do like you did, put one in each one of the paths?
For example, A, yeah. So
For every path, put a moderator.
yeah,
in there.
A, B, C,
Okay.
C prime, yeah.
Okay.
And the result interpretation. So which path we should focus on? For example, mediation, we should look at A times B. Okay, suppose we have A, B, C. Then if it's significant, then we can say that there's a mediation. And if the C prime is significant or not, we can tell it's complete or not. So how to do the interpretation of your result? That's for mediation part. For moderation, the same thing. Okay, what's the goal? Why do we want to look at the moderation model? What's the goal? What's the aim of this model? Basic path diagram. Again, you can consider 3 variables model. And equations. What's the equations for the moderation analysis? Result interpretation. So which variable, which coefficient we should focus on? If it's significant, then we can say there's a moderation effect. If it's not, then there's no. And also complete moderation, something like that. Okay. 4 points for the first part, 4 points for the second part, and we can also look at the hybrid models. This is 2 points because this one, it's I asked you give us some examples. That's it. Okay, just give us some examples of path diagrams and the working diagrams. This is 2 points for hybrid models. Yeah.
So in my understanding for the examples of the path models, we can basically use
X, Y, Z. Just just 3 variables case.
okay, so basically like the example you used in the note, we can use that for homework as well.
Yeah, okay, yeah, you can do that. Yes, it's a very basic model for mediation and also for moderation.
Okay.
Because I trying to push you to learn or review the moderation and mediation because it's really, really popular. In the near future or in your dissertation, or you're definitely gonna use those models, mediation and moderation. I just want you be very, very familiar with those models. Yeah. And that's it. Any question for homework 5? Okay, then that's for today's class. Okay, good, yeah. Yeah, that's it.
So
It's due next Tuesday. Yeah.
I'm very practical. All these equations confuse me. So this is the mediation equation right there, right?
That's one of the 2 because your BM, you've got another one that's going to be your other moderator. So there is.
So she asked for the 2 equations.
Yeah.
Yeah, so for mediation, we have 2 equations.
Yeah.
But for moderation, we only have 1 equation. Yeah.
I was just making sure.
Yeah.
Sound off in the deep end.
I'll make it a point to get this video to you guys as soon as I can tomorrow.
Oh, perfect.
So that way we can.
Yes, if there's.
I'm trying to get it to you all quickly.
Right.
Thank you.
No rich from-
So Dr. Lewis.
Yeah.
Would this be for my models? Would these be
Yeah.
considered moderators or mediators?
It's factor models. Actually, there's no mediation because you didn't draw the direct, there's no,
This
there's
is,
not
it's a
mediation.
direct causal
Yeah,
chain.
if you have this one, then you can think it's a mediation model, but you didn't investigate. So are you sure that the environmental worldview will not influence the?
So this whole first half is the value, belief, norms model. This
Okay.
is something that's been established.
Okay,
And this is the theory of planned behavior. That's
Okay.
another one.
okay,
And he's just saying,
oh,
so
okay,
I'm doing a survey and
Yeah.
I'm going to show how
Yes.
this
this good,
leads
this
into
good, yeah.
that.
But
So
when
this
you,
whole
yeah,
thing would be moderating on that, wouldn't it? Or mediating?
wait a minute, moderation,
Well,
which one will?
I don't know. That's
No,
what-
no moderation.
No.
No. I'm asking you, do you believe there's no direct effect from here to here?
According to all the other people that have used this model, they say no.
Oh, okay,
So this is a very popular
Oh,
model
okay.
by Stern,
okay,
and it's been around since 1991.
okay,
And this is it's the causal
I
chain.
see,
And they say this is a direct,
okay.
but,
No direct effect from here to here.
but the thing is there is, the way this model is designed
Uh-huh.
is
I think that
if someone has a positive environmental worldview,
Uh-huh.
they're going to have a positive awareness of consequence. But someone that doesn't believe, oh, littering is okay,
Uh-huh.
they have a negative environmental worldview, they're going to have a negative swear. So
Okay.
depending upon how they view
Okay,
this, they will have similar. So they're saying, if you don't give a shit about the earth, you don't give a shit about your consequences,
Mm.
you have no responsibility, and you have no norms.
How about this? Okay, this will this direct influence the behavior, what is that?
Behavior
intentions?
intentions to support nature-based
Will,
tourism.
is there any direct effect?
No, it's
No?
supposed to go through,
Oh,
because all of this leads up to what you believe,
okay.
how you view the big picture.
I see, okay.
These are all of your internal stuff,
I see.
and this, your personal norms, is what's
Okay.
going to influence it.
Okay.
And then all of these influence it.
Okay.
But if you notice,
Okay.
there are positives and negatives in here,
Okay.
negative
Yeah,
attributes.
okay,
But the only other,
okay,
you know,
okay,
okay. So,
yeah, okay, good, sounds good, yeah.
so,
All of these will be measured some items, right? These
Mhm.
are latent
Yeah.
factors, okay, good.
these all have,
Okay,
there's a standard set of questions you ask
okay, good, good.
that
I
will
love that.
identify that.
Good,
But
yeah. And sometimes, although the questionnaire is well designed for in general, but for some specific model, maybe we can just modify it. For example, drop some items because the item is not well designed. Then we can just drop, or we can just combine some of them.
Yeah.
Yeah, we can just do some edits.
yeah, that's why I'm asking, because these are very well-established models.
Oh,
But it's interesting because, like I said, in Asia or in the
Mhm,
Philippines, they love promoting their nature-based tourism and, oh, we got this beautiful sceneries.
mhm.
And then they turn around and they litter everywhere. Rivers of trash in Manila. You know, I'm like, you say you love the environment, but look at all the littering.
Okay, okay, yeah.
So,
okay.
and-
Okay, yeah. So you can, if you have time and energy, you can do some comparison. Okay, for example, the European countries, the Asian countries, Malaysia and also America. So if
Yeah.
you have two sets of data set, you can do the comparison.
Yeah. Well, and that's why I want to specialize in Asia Pacific. So I
Okay.
want to go around the,
Okay,
know,
that's good.
so
Yeah.
I'm looking at the Philippines, I
Yeah.
want to look at, Singapore, a bunch of these
Yeah.
other, all in
Yeah.
area. Have a
Yeah,
good evening.
bye, bye.
So,
Yeah.
I mean,